Hi everyone, this is Mrs. Chirigno, and this video is for my Geometry A students who do have a quiz over logic tomorrow, Wednesday, in class. I was not there in class today. There was a substitute when you were working on your quiz review, and I have received a few questions through email. So I just wanted to take a minute and do a real brief review of logic in general for your quiz tomorrow. What I do want to point out is that, and I was mentioning this in class on Monday, but I have taught you probably more than I needed to for that first quiz. So the quiz you're going to see tomorrow does not necessarily have everything on it that we've learned. I did that because I felt that the content really kind of all fit together and it made sense together. I didn't want to split it up. So, but just know that not necessarily everything that we've done so far will be on the quiz. Okay, and I'm going to try to focus on the key points here in this little video. Please be aware that I am at home with my two kids, so if you hear baby talk in the background or if you hear me start talking baby talk, just know that I do have some kids running around here and they are very curious about what I'm doing right now. So, okay, so logic. Sort of the fundamental piece of logic is the conditional statement, which looks like this. If something, then something else. Okay? And when you have a conditional statement like this, if it's a true statement, anytime this piece is true, that allows us to conclude that this piece is automatically true. Okay? So that's sort of the power behind a conditional statement, is it lets us link true statements together. Okay? So let's consider the statement, and I'm just going to throw an example out here. If it is Monday, then I have math homework, okay, which is certainly a true statement in our class. Pretty much every day you have math homework. So if it is Monday, then yes, you have math homework. Okay, so that means anytime it is Monday, I automatically know I have math homework. Now I want you to think about this. If I know that I have math homework, do I automatically know it's Monday? And hopefully you see that that answer is no, okay? Because it could be Tuesday and I could have math homework. It could be Wednesday and I could have math homework. Okay, but I know that on Mondays I always have math homework. So that's how a conditional statement works, is when you know the first part is true, which, by the way, hopefully you remember these terms, but that first part is called the hypothesis, and the second part is called the conclusion. Okay? So the first part is called the hypothesis, the second part is called the conclusion. Okay, so I'm going to take that statement we were just working with and kind of draw it in a diagram form. So if we know it is Monday, then I automatically know I have math homework. Okay, so making this jump from Monday to math homework is okay. However, if you're sitting down here and you know that you have math homework, you can't go the other way. That's why the arrow points this way. I can't say if I have math homework then it automatically has to be Monday. Most conditionals only work in one direction. If it is a case where it's true even if you do go back the other way, that's what we call a biconditional, and we have talked about those in class. That is one of the things, though, I can tell you that you do not have to worry about for the quiz tomorrow. Okay, and then we also said, like, for example, it could be Tuesday, and I could have math homework. It could be Wednesday, and I could have math homework. Okay, so you see that there are lots of different ways you can get to the conclusion. Okay, there may be a lot of different hypotheses. I honestly don't know what the plural of that word is. Okay, so you could have, I'll say it a different way. You could have more than one hypothesis that all lead to the same conclusion. Okay, that's why you can't go back the other direction, because I know on Monday I have math homework, and I know on Tuesday I have math homework, and I know on Wednesday I have math homework. But if I have math homework, that doesn't tell me a clue about which day of the week it actually is. Okay? That we were talking about right there is called the law of detachment. Okay, and I'm going to summarize all of the laws in just a second, but the law of detachment says that if you have a true conditional, so if it is Monday, then I have math homework, the law of detachment just says anytime it's Monday, then I know I have math homework. Okay, it lets you make that jump. So the law of detachment is really kind of a common sense type law. Okay, so let me just jot that down here. So with the law of detachment, if I have a true conditional, okay, so P implies Q, so if P then Q, anytime I know this is true, I automatically know this is true. I can't go the other way. I can't say that because I know this is true, then I automatically know this is true. But I can go in this direction. If P, then Q. Okay, so there's law of detachment in a nutshell. Okay, let's look at a different example. I'm going to start with that same statement. So, if it is Monday, then I have math homework. And again, we've got hypothesis, conclusion. Now let's say I add an additional true statement to what I'm working with. So take a look at this new statement. If I have math homework, then I can't hang out after school. So here, this is the hypothesis, and this is the conclusion. Okay? And notice that the conclusion here matches the hypothesis here. Okay, so the conclusion here was I have math homework, and the hypothesis here is I have math homework. And let me write that in symbols for you, and then I think it'll look more familiar. So let's say we're going to call this statement P. If it is Monday, I'm going to call that P, and then I have math homework, we're going to call that Q. Well, that means that this here, I have math homework again, is also Q. And let's just stick with that and go with calling this R. So the first statement is P implies Q, so if P then Q. The second statement is Q implies R. And here's another law for you. The law of, can you guess? The law of transitivity. Okay, and the law of transitivity says that if I can get from P to Q, and then I can get from Q to R, that I can make the jump all the way from P to R. So in this case, in the example that I did right here, I would automatically know if it is Monday, what? Think. If it is Monday, I could get all the way to what conclusion? Well, if it is Monday, I know I have math homework, and having math homework means I can't hang out after school. So I could put those two statements together and say, so when I put those statements together, this is what I come up with. If it is Monday, then I can't hang out after school. Okay, I'm jumping from the original hypothesis all the way to the last conclusion, and that's what the law of transitivity does for you. Okay? So hopefully that makes sense. Now I want you to think about that statement for a second. So we just said, if I know it's Monday, I know I can't hang out after school. Okay, what if I know it's Tuesday? Do I know anything one way or the other? No, I don't. Because this statement right here that I'm working with only addresses if it is Monday. So if it's Tuesday, I can't draw any conclusion at all because I don't know. Now I know on a previous slide we said if it is Tuesday then I have math homework might be true also, but let's just focus on this statement. If this is the only thing you have in front of you that's true, if it is Monday then I can't hang out after school. Monday is the only thing you know anything about. Okay, so if I ask you what conclusion can I draw if it is Tuesday, there's no conclusion to draw. The same thing. What if I say to you, well, I can't hang out after school today? Does that automatically mean that it has to be Monday? No, not necessarily. Sorry, my daughter dropped her bottle. No, not necessarily. It doesn't have to be Monday because there could be other reasons that I can't hang out after school. And that's that law of detachment again. The the law of detachment says the only way you can move is if you know the hypothesis, you can conclude the conclusion. That sounded weird, but that's why it's called the conclusion. If I know this is true, then I know this is true, but I can't move in any other direction. Okay, and I can't bring in any outside information. Just focus on the statement that's in front of you. Okay? So if it is Monday, then I can't hang out after school. Now I want you to think about this. What if I tell you that I can hang out after school? Okay? So the opposite of this, I can hang out after school. Can you think about what you would know then? Hopefully, you see that if you could hang out after school, then it couldn't possibly be Monday. All right? Because if it were Monday, you wouldn't be able to hang out after school. Think about that for a second. I'm going to say it again. If you knew, if you called me up and I said, yeah, I can hang out today, okay? And I knew this statement was true. And remember, when a statement is true, that means it's true for every possible situation. Okay, it's true for every instance. So every single Monday, this statement would have to be true. Whoops. If I was giving this to you as a true conditional. So if you called me up and I said, yeah, I can hang out today, you would have to know that it wasn't Monday. All right? Because if it was Monday, or if it were Monday, I would not be allowed to hang out after school. That right there that we called the law of the contrapositive. Okay, and when we talked about contrapositive in class, I'm not sure that we ever called this the law of the contrapositive, but maybe it would help if you thought about it that way. So think about a conditional statement, and I'll get back to what the contrapositive is in just a minute, but think about a conditional statement. Okay, P implies Q. So if I know P is true, then I know Q is true. If I know Q is true, that doesn't necessarily mean that P is true, because there could be other things that lead to that Q. But if I know Q is not true, I've got a good way to illustrate this. If I know that Q is not true, then there's no way that P can be true. Okay? Because if P implies Q is a true statement, and I know Q is not true, or I guess I shouldn't say not true, but is not the case right now, then there's no way P could be true. Okay? And that's what the law of contrapositive says, is if the conclusion is not true, sorry, I'm trying to write really fast and it's making my handwriting very messy, then the hypothesis can't be true, assuming you were starting with a true statement in the first place. Okay? That's what the law of contrapositive says, is if we know the conclusion is not true, then the hypothesis can't be true. Because if the hypothesis were true, the conclusion would be true. That's what a conditional statement is all about. Okay? Hopefully that clears up the laws for you a little bit. So let me give you, I was going to jump to a couple of examples. I'm really just kind of winging this, making it up as I go. Yeah, let's do a couple examples after I settled on my crying daughter. So let's take a look at this. If a shape is a square, then it has 4 sides. That's a true conditional statement. And we're going to try to draw some conclusions from this. Let me come up with a couple of examples here. All right, let's take a look at these 4 statements here. So we have a true conditional up at the top. If a shape is a square, then it has 4 sides. That is a true statement. And we are going to decide if we can conclude anything using these 4 statements, each one individually. So the first one, A, B, C, D is a square. Excuse my banshee daughter down there. A, B, C, D is a square. Well, that is a true case of the hypothesis, okay? So A, B, C, D is a square. That matches up with the first part of the statement, the if part. So if I know the if is true, I can conclude the conclusion, which is the then. So I can conclude, whoops, forgot to switch my pen, that A, B, C, D has 4 sides. Okay, that's what I can conclude from that statement. And that is the law of detachment. Okay, and I'm just going to put in parentheses here, detachment. Okay, so that you remember that that's what we used. I don't think on the quiz I'm going to ask you to specify the laws, but since we just talked about the laws, I want you to see them in action. I want you to understand why they work the way they do. Okay, so I had a true case of the hypothesis, and that let me conclude the conclusion, which is the law of detachment. Now look at the next one. MNOP has 4 sides, so that is the conclusion of this statement. Okay? If you know the conclusion is true, you can't do anything, because there's lots of ways that conclusion could be true. Yes, we know that if it were a square, that would be true, but there are lots of other things that have 4 sides. Maybe it's a rectangle. Maybe it's a parallelogram. Maybe it's just a random 4-sided object. Okay? So if you know the conclusion is true, there's really nothing you can draw. Basically, if you know the conclusion is true, that's the only conclusion you have. Okay, so this is no conclusion. But now I want you to think about, and that is sort of the law of detachment. What the law of detachment says is that you can only get from hypothesis to conclusion. You can't go the other way. So I guess the law of detachment is kind of working there too. Okay, just you weren't able to do anything with it. Okay, now think about this one. If I know that WXYZ is not a square, that means I know that my conclusion is not true. Oh. I worded that wrong. Hold on just a minute. I'm sorry about that. Well, I guess I should just roll with it and explain. That wasn't the example I was trying to show you, but that's what happens when I'm making things up as I go. If I know WXYZ is not a square, that is a case where we don't have the hypothesis to work from. Okay? The hypothesis is not true. This doesn't fit with the hypothesis, but that doesn't mean the conclusion isn't still true. Again, let's think about this. WXYZ could be a rectangle. WXYZ could be a parallelogram. So this is kind of the same case as up here. Again, it wasn't really the example I was trying to show you. I was just in a hurry and I wrote it wrong. But if you don't know the hypothesis is true, you really can't get anywhere. Okay? Or if you know the hypothesis is not true, I guess I should say, you can't make any conclusions from that. Your statement only allows you to work with this being true. If this is true, then this is true. Okay, and you don't know anything else. It's like this is the only thing that your brain knows right now. And then the same thing is going to be true. This is why I didn't mean to put that, because this example is almost the same. FGHJ is a rhombus. This statement only applies to squares. So I don't know what a rhombus is. I mean, maybe you do, but it's not defined for us here in this statement. So if FGHJ is a rhombus, I don't know anything about it based on this statement. Okay. Okay. I'm going to go back and do the example I meant to do a second ago. Let's see. There's an easy way for me to do this. Okay, let's look at this example instead. Suppose I gave you WXYZ has 5 sides. Well, that is a case where the conclusion, because the conclusion is it must have 4 sides. Oh, there she goes again. This is a case where the conclusion is not true. Okay, so let me just jot in here. And if the conclusion is not true, because I could just as easily have taken this statement, WXYZ has 5 sides, and said WXYZ does not have 4 sides, so anytime this is not true, then we have an untrue conclusion. And if it's an untrue conclusion, we know that this cannot be true, because if this were true, then this would be true, and it's not. Okay? So this one, we can make a conclusion. and I keep messing with all my colors here, the conclusion we can make is that the hypothesis is not true, which means we can say WXYZ is not a square. Now, we can't draw any sort of conclusions, at least not based on this statement, about what shape it is, but we know that it's not a square because if it were a square, it would have 4 sides. And that is the law of the contrapositive. Okay, so contrapositive is kind of a powerful thing because if you know the conclusion is not true, it does let you go backwards to the hypothesis and say that the hypothesis is not true. Okay, let's do something with the law of transitivity, just since that got a little bit left out here. Okay, and the law of transitivity is a little bit different. Just a second, sweetie. The law of transitivity is a little bit different because it involves 2 statements, 2 if-thens. Okay, so the law of transitivity, as I was saying, sorry I got interrupted there, I don't know if you could tell, but the law of transitivity includes 2 statements. You have to have 2 if-thens where the end of one matches the beginning of another. So notice that's what I have here. I have if a shape is a square, then it has 4 sides. And if it has 4 sides, then it is a parallelogram. So if you put those 2 statements together, what conclusion can you make? Okay, think about that for a minute. You should see if a shape is a square, then what? Do you see it? If a shape is a square, we know it has 4 sides, and if it has 4 sides, it must be a parallelogram. Okay, and that there is the law of transitivity. Well, I got transitive in there, not transitivity, but so if you knew those 2 statements were true, which by the way they both are true, think about this. Would you know that this statement is true? Hope you're enjoying your serenade of baby songs. Oh, and I spelled parallelogram wrong because I was trying to talk. Okay, so not the neatest work I've ever done, but all squares are parallelograms. Would that be true? If we knew this was true, if a shape is a square, it has 4 sides. If it has 4 sides, then it is a parallelogram. Does that mean that every single square would also be a parallelogram? Yes. Yes, it does mean that. Okay. Oh, and I still spelled parallelograms wrong. Oh. Oh, no. Nope, I didn't. Sorry, it just looks strange to me with the hyphen there in the middle. Oh, now I'm just babbling. I apologize. Okay, let's move on. Okay, we've talked about 4 different types of statements. We've talked about the conditional. In a conditional, we write in symbols as P implies Q, or if P, then Q. So P and Q are just statements of some kind, and we're saying that if the P statement is true, then the Q statement is true. The converse is formed by flipping those around. So Q implies P. Okay, so if the Q statement is true, then the P statement is true, and that's just backwards from the conditional. The inverse is where you negate, which means you say the opposite of P and the opposite of Q. Oh, I meant to write the opposite of Q. But that little squiggle means not P or not Q. Okay, the opposite of P, the opposite of Q. Really don't mind my daughter. I apologize if you can hear her. I don't know if you can, but she's teething right now, and she's just a little fussy. And then the contrapositive is formed kind of by combining these two things. Okay, so the contrapositive would be the negation of Q implies the negation of P. And I want you to think about what we were just talking about a second ago when we did the law of contrapositive. We said that if you had a true conditional and you knew that this was not true, then this was not true. Well, isn't that what this says? If Q is not true, then P is not true. These two statements, the conditional and the contrapositive, are what we call logically sorry, I just shrunk that. No, I can't write that small. Logically equivalent. And that means when one of them is true, the other one is true. And when one of them is false, the other one is false. So if I have a true conditional, that the contrapositive of that statement is also true. If I have a false conditional, then the contrapositive is also false. Okay? Now, just because the conditional is true doesn't mean the converse is true. And we sort of already talked about that. I want you to think way back to the homework example we talked about. If it is Monday, then I have math homework. We can't reverse that. We can't say if I have math homework, it must be Monday. So the conditional and the converse are not related. They could both be true, or they could both be false, or one could be true and one could be false. But I will tell you that the converse and the inverse are also logically equivalent. Okay, so if you had a statement and you wrote the converse of it and you wrote the inverse of it, they would either both be true or both be false. So logically equivalent means both true or both false. Okay. For tomorrow, what I really want you to focus on, though, are the conditional and the converse. Okay? The law of contrapositive is going to be useful tomorrow, knowing that you can make conclusions if the conclusion is false. But in terms of writing statements, conditional and converse are where I want you to focus your energies. Okay? Let's try one more thing, and then I'll stop talking. All right, let's take a look at this statement. If x is greater than or equal to 4, then x is greater than 0. So this statement says, if a number, a random number I'm thinking of, is bigger than or equal to 4, in other words, 4 or above, is it automatically bigger than 0? Is that a true statement? And to do that, you would have to know that it's true for every single number that's bigger than 4. Is every single number that's bigger than 4 also bigger than 0? Yes. So we would call this a true statement. So now, let's try writing the converse. Remember, the converse is formed by switching the conclusion and the hypothesis. That's what a converse does. Okay? So the converse of this statement would be, if x is greater than 0, then x is greater than or equal to 4. Which for that statement to be true, because remember, for a conditional to be true, it has to be true every single time this is true. So for every single number that's bigger than 0, is that number also bigger than 4? Hopefully you're thinking that's false. Okay? That is a false statement. Now, we prove a statement false with something called a counterexample. And a counterexample is one single case, one example of where the hypothesis is true, but the conclusion is false. Okay. So we want to find one single number, and there may be more than one, but we want to find one single number where this part is true. It is bigger than 0, but it is not bigger than 4. So I'm going to throw out, I don't know, 2. 2 could be a counterexample because 2 is greater than 0, but is not greater than or equal to 4. Are there other numbers you could use as a counterexample? Sure there are. Really anything anything between 0 and 4 would work. I could say 1.7 if I wanted to be fancy. Okay, so that's how you prove a conditional false. Proving a conditional true is actually much harder, and we haven't even talked about that. But proving a conditional false is actually easier than proving it true because you just have to find one case where it's not true. Okay, I think that's it. I think that's the basics or the basic premise of what you're going to see on your quiz tomorrow. I don't have the quiz at home with me, but I have looked at it. So I think that if the stuff we just talked about makes sense to you, you should be in good shape. Okay? If there are some tiny details from yesterday's assignment that you want to talk about tomorrow in class, we can. I'm also around tomorrow morning before school if you want to stop in, and I'm also around during lunch. If you are going to come in during lunch, you'll need a pass from me ahead of time, so you'll have to swing in sometime earlier in the day to get one. The other thing I want to recommend is that you email me, because I will respond back to emails with specific questions. You can ask questions from the quiz review, or you can ask questions from this video if you had questions about the stuff I talked about. Oh, listen to me talking and writing and making a huge mess of it. Sorry about that. So here's email address if you do need to contact me. You can also contact me through Twitter. Okay, and actually that might be a good idea if you are on Twitter, because I'll respond to you there, and then other people can see the discussion we're having. Okay, which means if they have the same question, they could, read our conversation and be set. And then also, I did post an answer key on the website. Now, I'm guessing you probably found this video on the website, so you probably already found that answer key. But an answer key for the quiz review is on my website, and I'll take a second and write that on here for you. Okay, so my website is cherignomath.weebly.com. Look under Geometry A, Unit A, and that's where this video is posted also. So hopefully you should see it right on the same page you found this video. And again, feel free to email me, stop in tomorrow morning, whatever I can do to help you before tomorrow. Okay, happy studying.